A fitness tracker company is analysing the average number of daily steps taken by users. The larger population of users has an average of 7,500 steps per day, with a standard deviation of 1,200 steps. What sample size is needed if you want to be 95% confident that the mean of the samples taken differs from the population means by less than 200 steps? And while we're at it, part B is just going to be a 99% confidence interval using the same stuff. So what do we want here? We're trying to produce a 95% confidence interval. The center of that interval would be here. And we want the width of this interval to be 200. Well, the width of the interval is going to be 400, but it says within 200 steps of the mean, so that's 200 either side. So if I use the formula as given by the E activity, because most often you're going to be using the E activity, which is Z sigma over E squared, that is telling us that the E is equal to 200. The X bar, or the population mean if you like, the mu, is 7,500. Not that that actually makes any difference because it doesn't appear in the formula. The standard deviation, or the sigma as it is in the formula, that is going to be 1,200. And we want a 95% confidence interval. So we need that Z-score. So what we're going to do is we are going to get the calculator, because this is how you're going to do this nearly every time anyway. We are going to do Z-score for CI first, and we're wanting 95%, so we're going to go 0.95, and then we're going to go solve, and we get the familiar number up here for the Z-score, and then we're going to go into sample N for CI. Notice how it's put the Z-score in there for us, which is just great. We're trying to find N, so leave that one there. Our sigma is 1,200, and we want E to be 200. And then we're just going to hit solve, and it does it. It tells us N is equal to 138.29. Now, N has to be a whole number. If N was 138, we'd find that this was slightly wider. And remember, the root N on the bottom, when we do the standard area, which is either S or up there or sigma up there, the root N on the bottom, if N is a smaller number, then this number is going to be slightly bigger, giving us a slightly wider interval. We want it to be less than 200 steps. In other words, we'd rather it was in here. The exact width there is given by 138.29, but we need a whole number. So this is a situation where we round up. Even if that was 138.001, we'd round up. So it's 139. And then for the 99%, the only difference is that it's a 99% confidence interval. And we can do it in exactly the same way. So we are going to just OK that. We're going to go back to Z-score for CI. We're going to change to 99% here. And we are going to solve to get our new Z-score. When we go back to here, we can see that new Z-score has been put in, and we can get rid of that value there. The other things are all the same, and we're just going to hit that, and it's 238.86. And again, we're going to round up to 239.